Welcome to my channel. This is here the 5th problem for the chapter of inverse circular function of trigonometry. Okay, and this type of problem are more useful in some problem that is useful for the limit theorem, useful for the integration, useful for the derivatives, and so other many form of application. So see, so here it is given that the question number 1, okay, that is tan inverse 1/3, tan inverse 1/7, and tan inverse 1 by, that is n square plus n plus 1. So this is the nth term. Okay, this is the nth term. This is the more useful term for the question number 1. So let us assume this is Tn here. So therefore tan inverse that is 1 by n square plus n plus 1. Okay, and this formation can be written as see here carefully, more useful, that is here 1 plus take a common n from the other two. That is, if we subtract on the numerator part, then we got a formula. So this is equal to, we can write tan inverse n plus 1 minus tan inverse n. So putting n equal to 1, 2, 3 up to n. So here putting n equal to 1, 2, 3 dot to n. Then if you put 1, then you get here 1/3, tan inverse 1/3 c. So tan inverse 1/3 is equal to, we can write here, put here 1. So this is 2 minus tan inverse 1. If we 2 here, then we get here 1/7. So here is tan inverse 1/7, and that is equal to tan inverse, if we put here 2, so that is 3, and put here 2, that is tan inverse 2. Okay, and so on, and so on, and so on. This is here tan inverse 1 by n square plus n plus 1. So we get here, that is tan inverse n plus 1 minus tan inverse n. Okay, then sum, do the sum here, then we get the condition, that is tan inverse 1/3, that is here tan inverse 1/7, and dot plus tan inverse, this is a 1 by n square plus n plus 1. Okay, and see, if we added this series, then we cancel this, and this term are cancelled to the next term, and this term are also cancelled to the previous term. So you get here, we have left here on the ending term is this, and okay, and this is your answer, tan inverse n plus 1 minus tan inverse 1. Okay, and see the option there. So that is a single tan inverse, so apply the formula here, tan inverse x minus tan inverse y. So therefore n plus 1 minus 1 by here 1 plus n plus 1 into 1. So we got the answer here. So this is, so n by n plus 2. So see the option, that is first option. Okay, that is first option. Carefully, this is very interesting question for number 1. Okay, now follow the question number 2. This is here 2. Okay, this is summation, and this is a summation. I think limit here missing. So, oh, this is a summation. Okay, no. this side. This is a summation. So now Tn, that is, let us assume this is Tn, tan inverse 2k by k to the power 4 plus k square plus 2, and this can be written as like tan inverse 2k by 1 plus k to the power 4 and k square plus 1, and the factor of that, now k to the power 4 plus k square plus 1, this is equal to k square plus 1 whole square minus 2k square and plus k square. So we get here k square plus 1 whole square minus k square. So therefore k square plus 1 plus k and into k square plus 1 minus k. Okay, this is the two factor. Okay, so in that case we can write here, so this is tan inverse, this is Tn here, Tn, that is tan inverse, we can write here like now 1 plus, that the product of 2 is this, so we can write k square plus k plus 1, and here is k square minus k and plus 1. And this is x into 1, as it is a plus, so there will be a subtraction, this minus is what happens here, this is k square plus k plus 1 minus k square minus k plus 1, okay? See, and this is a 2k, okay? So therefore split the formula, and that is a k square plus k plus 1, okay? Now tan inverse k square minus k and plus 1. Okay, this is your Tn. This is your Tn. So now this is your form k equal 1 to n. So therefore now T1. Okay, this is your 1 to n. That is T1. So here is tan inverse 3 minus tan inverse 1 here. Again T2, that is here, if we put here 2, then we get here tan inverse 7, we get here tan inverse 7, okay? Four to 6, 7, okay? Here is tan inverse, if we put here 2, 4 minus 2, 2, and this is there 3, okay? Same as we can write here, this is t suffix n is equal to tan inverse up to n, so up to k equal 1 to n, so that's why in place of k we replace n, okay? N square plus n plus 1 minus, so tan inverse n square minus n plus 1. Okay, see, and do the sum. That is, you can say that Sn, and that is also, notation here is like that, k equal to 1 to n. Okay, k equal to 1 to n, and that is tan inverse. We can write here 2k by 2 plus k square plus k to the power 4. And it is the sum. So see, these two terms are cancelled, these are also term cancelled, so these terms are cancelled to the previous term. So we get here tan inverse n square plus n plus 1. See the option minus pi by 4. Okay, there is a, we have left here minus tan inverse 1. This is minus pi by 4. So you can write here minus pi by 4 plus tan inverse n square plus n and plus 1. Okay. See the solution carefully. Okay. Okay. Next solution. For 3 here is Now cot inverse r square 3 by 4, that will be cot inverse, you can write here r square minus 1 by 4 and plus 1. Okay, and factorize this, so this is cos inverse is r minus half, r plus half, and r minus half, and this is plus, and cot inverse r plus half, and this is here r minus half and plus 1, and subtraction of these two. Okay, so sum is 1, so this is here 1, so we can apply the formula, that is cot inverse r minus half minus cot inverse r plus half. Okay, the sum here, summation. So now we have to find the limit also there. Okay, this is a, let us assume as a tn, so tr, this is as a r. So now first I have to find t1, so that is half minus 3 by 2. Again t2, that is cot inverse, if put 2, that is 3 by 2 here, and minus cot inverse, this is 2, this is 5 by 2 here. So similarly we can proceed the up to this is here in term, this is tn, so you can write here tn, this is here cot inverse n minus half and minus cot inverse n plus half. Okay, and do the sum, so therefore we can write here Sn, and also it can be written as, so here r equal to 1 to n here. Okay, and we can write here cot inverse, and this is an r square plus 3 by 4, and it will be that is here cancel to the opposite direction, this is here cross. Okay, so it can be cancelled to with this direction, so this is okay right now. So now left hand cot inverse half, and this also, so cot inverse half minus cot inverse n plus half here. Okay, now we have to find that is there tan inverse 2, their answer is. Okay, now we can write here like it is tan inverse 2 and it is tan inverse. If you take a LCM, that is 2 here, so this is 2 by 2n plus 1. Okay, limit here n tends to infinity, as the limit n tends to infinity, and this is Sn, and limit n tends to infinity, thus the summation are equal to 1 to n, and cot inverse r square plus 3 by 4, and this will be, this is tan inverse 2, not needed to the limit here. So now here, and now like right, n tends to infinity, and we have here tan inverse, that is, and 2, and take a common n here, so we have 2 plus 1 by n here. So see carefully, and 1 by n tends to infinity, so 1 by n is equal to 0. So here, get here tan minus 2, tan inverse 2, and here is tan inverse, this is 0 by 2 plus 0 here. So this is whole thing is 0, so the answer is here tan inverse 2. Okay, so this is third complete. Okay, 1 2 3 complete here. Okay, now for the question number here 4, limit n tends to infinity. Okay, this is n tends to infinity, and summation r equal to 1 to n, and this is a cot inverse r cube minus r plus 1 by r by 2, and this is equal to, limit n tends to, not needed to sum here. See, this is cot inverse 2r, r to the power 4 minus r square plus 1, and this is here cot inverse a plus b a minus, so r square minus r, so r square plus r, so this is a plus 1, so you have right here, I can write here like r square plus r, this is r square minus r, okay, so this is here cot inverse r square minus r and cot inverse r square plus r, okay, and we want to find the summation, so this is greater than Tn, so Tr, this is r, okay, so putting r equal to 1, 2, 3, dot dot 2 up to n, then T1, this is a cot inverse 0 minus cot inverse 2, T2, this is a cot inverse 4 minus 2, this is 2, and this is cot inverse 4 plus 2, this is 6 here, T3, so cot inverse, if we put 3, so 6 square minus 3 square minus 9 minus 3, that is 6, and cot inverse 9 plus 3, that is 12, okay, and so on. This is this is here, okay, Tn, that is cot inverse a square minus n minus cot inverse a square plus n, okay, and take a sum, okay, this summation, this is T Sn, and this is Sn is equal to, look here, the summation is 2 are cancelled, these are cancelled, these are cancelled, so this cross, these are cancelled, we have got there, that is cot inverse 0, minus cot inverse n square plus n, okay, cot inverse 0, that is tan inverse 1 by 0, okay, this is pi by 2, this is here pi by 2 minus tan inverse 1 by n into n plus 1, okay, this is here limit n tends to infinity, and this is here sum Sn, so therefore we get here pi by 2 minus, this is as a tan inverse 1 by 0, means infinity, 1 by infinity, okay, and take a common n square, so this is 0, so 1 plus 1 by, and this is 0 here, so we can write here this is 0, this is equal to pi by 2, okay. Now follow the second question, very important question, 4, 5 and others, see carefully. Now follow the fifth question is that, so it is as Tn, okay, and Ti, now cot inverse 2r square, so you can write here tan inverse 1 by 2r square, this is tan inverse, okay, 2 by 4r square, so this is here minus 1 and this is the plus 1, okay, so tan inverse 2 by 1 plus 2r plus 1, and this is a 2r minus 1, so you can write here tan inverse 2r plus 1 minus 2r minus 1, so therefore 1 plus 2r plus 1, and this is a 2r minus 1, so you can write tan inverse, this is 2r plus 1 minus tan inverse 2r minus 1. So now we have to find T1, this is Ti. So putting I equal to 1, 2, 3 dot to n. So this is T1. If we put 1, then we get here tan inverse 3 and minus tan inverse, this is 1, T2. So tan inverse, this is 2, this is 3, okay, no, this is 2, so 4, 5, so minus, if you put here 2, 4 minus 1, 3, okay, and so on. This is Tn, so tan inverse 2n plus 1 minus tan inverse, this is 2n minus 1, okay, so this is Sn. So after the sum we get here, these are these cancel, across are cancelled, so these are cancelled, so you get here tan inverse 2n plus 1 minus tan inverse 1, okay. So now here, this is n tends to infinity, so summation limit n tends to infinity, so this is Sn, so you can write here n tends to infinity, so this is here tan inverse infinity 2n plus 1. If we put here infinity, so this will be infinity, this is tan inverse 1, so that means pi by 2 minus pi by 4, this is here pi by 4, cot inverse 0, okay, pi by 2, okay. Very important classes for the okay, right.